I've been struggling with the last two recently, so. I have 18 tomorrow, so you better teach me a lot before that.
You're probably not going to get a whole lot out of just this one class. So obviously, what's an inequality?
It's greater than.
Yeah, okay. So our two basic ones are less than or greater than. And if we think about inequalities just in general, it's a comparison, right? We're making a comparison between two numbers or variables and a number. What's the biggest difference between inequalities, which are these two signs, and equals? Inequality problems have what?
A number included or like a number.
Okay, but how many answers would we say inequality problems have? A lot, right? There's basically an infinite number of answers. So that's one of the biggest differences. And remember then, usually this is less than. And if you tilt your head, you can kind of see that it's an L. Okay, this is usually greater than. But in reality, it's all how you look at the problem. Meaning how you read the problem. Do you always want to try to read left to right, or do you just want to read it and put the variable wherever you want? Personally, I like to always put the variable on the left-hand side. And then I always know that this is less than and this is greater than. But if we're comparing two numbers straight up, it's always going to point towards which one? The lesser one, right? It points towards the smaller number. It looks like it's quote-unquote eating the bigger one. And that's how we know. So then we look at, and this chart is in your book, but hopefully these things all should make sense to you. Comparison, that's what we just talked about. We can still do the transitive property. If A is bigger than B and B is bigger than C, then we know that A is bigger than C. So we're plucking out that B again, and we're just doing the transitive property like we've done. And then obviously the addition property means that if A starts out being bigger or smaller than B, and you add the same letter to both sides, it's really not going to change the problem, right? If you know that 4 is greater than 3, you can add 5 to both sides and you still get the same greater than sign. Okay, so that's all that those were showing. Not going to make a real big deal about those. So we get into a theorem. So this goes back to an exterior angle. Do we remember what an exterior angle was compared to our figure? Everybody tried to draw a triangle. And this bottom one extended a little farther. Okay. So extended a little farther. Where's my exterior angle? Let's just put some numbers in here. Let's name this 1, 2, 3, and 4. Which one of these would be an exterior angle? 4 is my exterior angle. And what was true about 4 compared to some of the angles in my triangle? 1 and 2 equal 4. So angle 4, the measure of angle 4 equals the measure of angle 1 plus the measure of angle 2. So realistically, what would we know about 4 compared to 1 and 2? It would have to be what to them? 4 would have to be what compared to those, each of those individually? Greater than, right? There's no way that angle 1 can be bigger than angle 4 and have this be true. And this is, by definition, what an exterior angle is. So that's what we're going to talk about today. Theorem 5.8. Which is the exterior angle inequality theorem.
Please pardon this interruption. We need to restart the network. So if you are working on anything, please save it at this time. We'll plan on restarting it at about 8:45, so if you could get your stuff safe before then. Sorry for any inconvenience. Thank you.
How long is this gonna last?
Well, it's 8:40. You got 3 minutes.
No, that is gonna be shut down.
No, I don't know.
I understand I have 3 minutes, but I need the other part of it. Anyway, alright, so, exterior angle theorem.
So I think it's gonna shut
The measure of an exterior angle is greater than the two remote interior angles of any triangle. Now this is where, so basically these figures, and this is where I'm kind of worried because we need to see these figures here. But anyway, these figures that we're going to look at, they're going to try to challenge you because they're going to try to make them kind of really odd looking and put a lot of things into it. So here's where you got to be careful. If I looked at this right here, how many people would say that angle 4 has to be bigger than angle 3? I'd probably say so too, right? Especially by the look, okay? But in a linear pair, does it have to be that 4 has to be bigger than 3? Not necessarily, right? And this is where we always said, don't look at the picture. Think about what you know. So in this case, they're going to ask you in the assignment, name all of the angles that are less than angle 4. But you have to have a reason why that angle is less than. So our reason why angle 1 and angle 2 are because they are remote interior angles to our exterior angle. I can't really prove that angle 4 is bigger or smaller than angle 3 by what's given to me. Does that make sense? Even though it by far looks like this is an obtuse angle, and we know that that has to be bigger than that angle 3, which is an acute angle. But does that make sense? So when you get to your assignment, you cannot go by the look of things. You have to go by what we have learned. And that's this theorem right here. Make sense? Now you can use other things that we can prove, or we know that are definitely true. I never know what is true about a linear pair. But I can use vertical angles because we know the definition of a vertical angle, right? They are congruent to each other. So if one angle is bigger than the other, and then it's congruent to another because of vertical angles, obviously it's bigger to the third one. That's our transitive problem. Okay? And we'll make more sense of this in a little bit. So we gotta get right in here before we lose our problems here. The last thing that we're going to talk about are the angles and the sides. So we're going to call angle side inequalities. What this means to me is that, remember how we said the angles and the sides opposite of them kind of go together? They're corresponding. So when we draw a triangle, and we call it ABC, and I tell you that this right here is 65 degrees. This up here is 85 degrees. We can find out what this is right here, right? Because we would do what? Add them up and subtract it from 180. So 80 and 60 is 140, 150. So this is 30 degrees. And again, it might not look like that to you, but it is. Okay? So from there, then, what this is saying is this angle and that side over there go together because this is huge when we get into trigonometry. If this is capital C, this length of this side could also be called lowercase c, right? The distances of sides are the lowercase letters, the angles are the capital letters. So down here, if this is capital B, this down here would be what? Lowercase b, and so on and so forth. So this would be little a. But what we're saying is the angles and the sides opposite of those angles go together. Now this is where we ran into the little problem the other day, because if they said that this was 85 degrees, even though that they go together, some of you just thought, well, then B had to be 85. And that's not true. They're corresponding, meaning they work together, but the actual measurements don't go by the degree measure compared to the length of the sides. That makes sense to everybody what I'm saying there? Okay? So, it leads us to two more theorems. And hopefully, by what we're saying here, these theorems will make sense. So the first one's theorem 5.9. And this one says, if one side of a triangle is longer than another, the angle opposite that side has to be bigger than the shorter side. So I drew the first one using the angles, so this will end up being theorem 5.10. What this is saying is this. If they show me that one side of a triangle is longer, they show me that this is 17, and they show me that this is 10. Then, by theorem 5.9, the angle opposite of it would have to be bigger than this angle opposite of 10. And would that make sense to you? If the side is longer than this side, the angle opposite has to be bigger. So if we name it again ABC, because AC is 17 compared to AB, which is 10, I know that angle B has to be greater than angle C. Now, do I have any idea what the last one is? Not necessarily. But if we look at this, and I know we say that we should look at it, but if this is what I would call the longest side, and this is bigger than this side, then realistically it should be bigger than that side. But as of the information given to us in that particular triangle, we don't necessarily know if this side is bigger or smaller than this side, just because they didn't give us numbers. So then they would have to give us another number. This looks to me like it's a little bigger than the other side, so we'd call that one 15. So then we know that this angle, A, would be the middle size angle of the triangle. And that's going to be true every single time. So you can look at the lengths, and the angles opposite of them would go in the same order. So they might ask you to list the angles from least to greatest, or greatest to least. And then you would just put them down. Okay, so 5.9, you're given the sides, and you're going to talk about the angles. Theorem 5.10 is basically what I drew out over here first. Okay? If one angle of a triangle is bigger or greater measure than another angle, the side opposite, the greater exterior angle has to be bigger. So again, if we went back and we said, or we looked at the first triangle that we drew up here today, what side would you say has to be the biggest or the longest side? AC or little b, right? And what would be the shortest side? Little c or AB. That makes sense to everybody? Again, we're going diagonal or crossing. Okay? So I don't get the whole network thing. Why didn't anything shut down? What? Well, I know, but I'm using it there, and it never shut off. No, but like down here, this little, you know, the little icon thing, major, it never shut down. Maybe it's just like a flip of a switch. They can just turn it on, turn it off. Anyway, sorry. Questions with the words? The words to me aren't that confusing. Some of the examples are. So, here's the one that gets confusing right here. Right? So, what did you say? Use the exterior angle inequality theorem. So again, I can only use the things that I can prove. So back to the concept of the linear pair. Even though angle 4 in this example up on the board looks like it's way bigger than angle 3, I cannot come to that conclusion. Because realistically, I have no idea until they tell me what angle 4 is. So over here, obviously, if you looked at 15 and 6, 15 is way bigger than 6 by the look, right? Because in a linear pair, obviously, this is an obtuse angle. But you cannot say that angle 15 is bigger than angle 6 because of a linear pair. Make sense? All right, so let's look at this. Use the exterior angle inequality theorem to list all angles whose measures are less than angle 14. So everybody see where angle 14 is? Angle 14 is right here. So we're going to think about angle 14 being an exterior angle to what triangle? That's what you got to zone in on. What triangle is angle 14 a exterior angle? Would you agree that it's that triangle right there? Would you everybody agree with that? So what two angles is 14 bigger than in that particular triangle? 4 and 11. Everybody agree with that? Okay, now, do you realize 14 is an exterior angle now to that big triangle right there? So now we would say it's bigger than what angles? 2, 3, and 4. 3 and 4 because they make up the same one. But we already had 4, right? So we would have said 2, 3, 4, and 11. Definitely, right? What do I know about 11 and 9? They're vertical angles. So if 14 is bigger than 11, can we realistically prove that 14 is bigger than 9? Yes, because of vertical angles. Okay? Now, if 14 is bigger than 9, wouldn't you say that 9 is the exterior angle to 6 and 7? This 9 right here, exterior to that triangle right over there. So if this is exterior to that triangle, 9 has to be bigger than what? 6 and 7. So is 14 bigger than 6 and 7? Yes. And then we'd come back here and say 9 is the exterior angle, but we already had those two, 2 and 3. So realistically, we should have said that, this one right over here, and this one right here, and then 9. So we should add 1, 2, 3, 4, 5, 6, 7. That make sense? Let's see if we did it right. 1, 2, 3, 4, 5, 6, 7. We did it right. So let's try again. This one now, I think that one's easier when it says list all of them that are less than whatever angle. This one says find the angles whose measures are greater than angle 5. To me, this is a little bit more confusing. So basically, you got to think about where is or what is or when is angle 5 a remote interior angle to some exterior angle. So again, look at where angle 5 is, and maybe you have to again draw this on your paper, and on your paper, not in your book. So here's my triangle, right? Where angle 5 is at. If it's a remote interior angle, that means what would have to be an exterior angle to this triangle? Okay, 17 would. Perfect. Any others? 12 would. Going the other way. Any others? 14. 14 would. Okay. But is 14 yes, 14 is an exterior angle, but is 5 a remote interior angle to 14? So really we can outlaw this one. But you're right, it is an exterior angle. What else? Any others? 10. Okay. Any others? So would you agree that those 3 that we circled have to be bigger than 5? And are there any others that you could see? What about 15? 15 is an exterior angle to this triangle right here. And does it have any relationship to that angle 5? Probably not. But it is an exterior angle. You're exactly right. Okay? Any others that you can see? So let's see if we got them. We said 12, 10, 12, and 17. They said 10, 12, 17, but they include 15 and 16. So, Merrick was right. 15 and 16, because if it's exterior to these, the reason why is this. 15 is exterior to 12, and so 12 was exterior to this one. And so if 15 is bigger than 12, 15 also has to be bigger than 5. So you're exactly right. That makes sense? So these are a little confusing. I'm not arguing whatsoever. But just make sure you go real slow and look at it. So try this one right here. So we're looking for the angles that are less than angle 4. And again, by ways that we can definitely prove it. So I cannot say that angle 4 is bigger than angle 3 because it looks like it. Looks aren't a reason why. So what do you say? 2 and 5 definitely? 8 and 7 because of the bigger triangle, right? Any others? And what? Why 6? Is it? It's a great thought, Bo, but what do you need in order to have alternate interior angles? Parallel lines. Is there any proof of that? No. So that's a great thought, though, Bo. But he's wrong. This time. Okay? So, just those 4, you think? Because now, you see that this little triangle right here, and then I'm going to go to the big triangle. And the big triangle is my 8 and 7. Okay? So, boom, those 4. Make sense? Okay? Then we go into the ones that I personally think are a little easier. So this basically just says list the angles in order from smallest to largest. So what is my smallest angle by the numbers here? Angle C. My biggest one? B. That's it. Make sense? Hopefully those are a little easier. What are other ways that they could say smallest to largest or largest to smallest? Least to greatest. They could say ascending or descending order. Okay? And then the angle ones are basically the same thing. So again, when you do the angles, or you're going to write down the sides, remember you can do the sides two different ways. You can use the capital letters, meaning AB, then you need to write it as a segment. But you really don't need the segment thing now because we're talking about lengths. But capital A, capital B, or you could use little c. So that's totally up to you, however your melon wants to do it. So, shortest side. AC, longest side. Everybody good? Lauren, you look confused. Lauren, come on. Lauren, look. Here's my biggest angle. So the side opposite of that side, or that angle, has to be the longest side. And vice versa. So if this is my smallest angle, this side over here has to be my smallest side. Okay? I think that's probably it. Let's read a story from. You always have to have one on Friday. Tiny is following directions for making a kite. She has two congruent triangular pieces of fabric that need to be sewn together along their longest sides. The directions say to begin sewing the two pieces of fabric together at their smallest angles. At which two angles should she begin sewing? What two angles are the smallest? A and D. Everybody get why? Okay. Questions? To the question that the ladies had earlier, are we going to get a review? Yes. You'll get a review on Monday. So notice the quiz on Monday. First 3 sections. And then I'll give you the review. What we'll do next week is on, I believe,